Welcome to Study Loop.
Chapter 13, problem number 48. And so this problem is asking us to treat benzaldehyde with zinc and mercury amalgam in hydrochloric acid. And we're given several pieces of spectroscopic evidence and asked to try to determine the product of that reaction. And so there are really two ways to approach this problem. So first, what I've written down here in green, these conditions, zinc and mercury amalgam and hydrochloric acid, are what's known as the Clemmensen reduction. And so I've written Clemmensen reduction here in green. And as you progress in organic chemistry, you'll learn, you'll just memorize some reaction conditions and what they do. And so the Clemmensen reduction is a method for reducing ketones and aldehydes to the corresponding alkanes. So when I first looked at this problem, that was how I got to this answer down here. I've written the answer in red. So Z is just toluene. And so I got that answer by saying these are Clemmensen reduction conditions. Therefore, they're going to reduce away the aldehyde and leave you with just the methyl group there. But it is important also to look at this spectroscopic evidence that we have. And so the first piece of evidence that we're given is that the mass to charge ratio when compound Z is analyzed by mass spectroscopy, we get an M to Z of 92. And so 92 breaks down or can be broken down into 7 times 12. 12, of course, is the atomic weight of carbon, plus 8 times 1. That equals 92. And so from that, we determine we have 7 carbons and 8 hydrogens. And that makes sense if we look at our starting material. There's 6 carbons and 5 hydrogens in this ring, and then another carbon out. In the starting material, the carbonyl carbon would be your 7th carbon. And then when you start to think about what possible products of this reaction could be, if you were to think of this toluene molecule, you would see that it fits that M to Z that we're given. And then lastly, looking at the IR really doesn't tell us too much here. So we have peaks between 3150 and 2950. And so that's our CsP3 hydrogen and carbon, sp2 carbon hydrogen bonds. And then we have peaks at 1605 and 1496. And those peaks are from our aromatic ring here. One thing to note from the IR is that there is no carbonyl stretch, which would be, roughly 1700. And we don't see that. And so that's, a further piece of evidence that this aldehyde has been reduced, and we just have this alkane. And so that is the answer to number 48.